Unit 7, Day 3 video notes, functions. Okay, I have reproduced here the chart, one of the charts from your book, so that I can show you how this works. You'll notice on the left we have the activity, we have jogging, swimming, tennis, walking, bicycling. And on the right, calories burned, 110, 270, 210, 120, 330. So on the left, we refer to as the domain. This is the input of the function. And on the right is the output, or what we refer to as the range of the function. The domain will always be on the left, the range will always be on the right. The input on the left, the output on the right. So they've asked for what the domain is, and off to the right of this chart I've listed the domain. You'll notice that I used brackets, used set notation to give us my domain: jogging, swimming, tennis, walking, bicycling. And then they've asked for the range. Now you'll notice that the range only has 4 values, and they're not in the same order they are in the chart. The reason for that: one, if a value occurs more than once, we only list it once. And the second thing is that in the case of numbers, we list them in order from smallest to largest. And so I've done that. I've listed 120, 210, 270, and 330. And then they've asked us to list each of these as ordered pairs, which I've done. I've put jogging, the input, notice it's in the X position, and the output in the Y position: jogging 210, swimming 270, tennis 210, walking 120, bicycling 330. Fairly simple there. I also wanted to show you examples. They asked for a bar graph, and I've created a bar graph here. And they asked for a broken line graph, and here's a broken line graph from the same data. Okay, moving on. Function notation is really just a different way to write an equation. And the point to function notation is to focus on that there's an input and an output, a domain and a range. And so, first line here, we've got one way to write function notation with the f or whatever letter we're using for the function, and then x or whatever variable we're using in it, and an arrow indicating that this function maps to this expression 3x minus 1. Then we have what's probably the more common function notation. I would read this as the f of x equals 3x minus 1. But it's the function using x that equals 3x minus 1. And all of this is really just the same thing as y equals 3x minus 1. We deal with it exactly the same. The point being, however, that we put something in and get something out. Okay, graphing linear and quadratic functions. And I'm using a modified t-chart so that we have a place to do our calculations. Now, I want to start sort of near the beginning of the graph, so I'm going to start with a value of 0 for x. And then we have this x squared minus x equals 6. So we need to substitute in 0. So we have 0 squared, and the parentheses are just my notation to myself that I'm substituting. Minus 0 minus 6. And when I do that, 0 squared is 0, minus 0 is still 0, minus 6 gives me negative 6. Okay. So I'm going to put in a 1. Whoops, I put that in the wrong spot. I'm going to put in a 1 and a negative 1, and we'll try each of those and see where we're at. So 1 squared minus 1 minus 6. And when I do that, 1 squared is 1, minus 1 is 0, minus 6 gives me negative 6. Both values are the same. Okay, so let's go down to negative 1. So I've got negative 1 squared minus negative 1. Notice that's important right there. Minus 6. So now, of course, negative 1 squared is positive 1. And this minus and negative, those cancel out. So this is actually 1 plus 1, which is 2. And then 2 minus 6 is negative 4. Okay, let's come up here to 2 and try that one. So 2 squared minus 2 minus 6. 2 squared is 4. 4 minus 2 is 2. 2 minus 6 is negative 4. Interesting. We're starting to get some symmetry here, aren't we? Okay, let's try some more of these. Okay, let's put in 3. And so 3 squared minus 3 minus 6. 3 squared is 9. 9 minus 3 is 6. 6 minus 6 is 0. Okay. Let's try to move down here and do the negative. So negative 2. So when I put that in, I've got negative 2 squared minus negative 2 minus 6. Negative 2 squared is positive 4. Of course, those two cancel. So positive 4 plus 2, that gives me 6. 6 minus 6 is 0, or symmetry. Okay, let's put in a negative 3. So negative 3 squared minus negative 3 minus 6. Negative 3 squared is positive 9. And of course, those cancel out. So positive 9 plus 3 is 12. And 12 minus 6 is 6. Okay, let's go back up here and see if our symmetry continues. So now I've got a 4. I'll put in 4 squared minus 4 minus 6. So 4 squared is 16. Excuse me. 16 minus 4 is 12. And 12 minus 6 is 6. Okay. So let's take a look at what we have here thus far. If I look at this, at both 0 and 1, I have a negative 6. So let's see here. 1, 2, 3, 4, 5, 6. At 0 and 1, I have negative 6. At 2 and negative 1, I have 4. So there and there. And then at 3 and negative 2 is 0. Here and here. And then at negative 3 and 4, I have 6. So 1, 2, 3, 4, 5, 6. And same thing over
there. This is sort of U-shaped, which means there must be a point down here between the two of these, and we need to figure out what that is. So let's put in an x value that is halfway between. As this is symmetrical, it pretty much has to be halfway between the two of those. So let's go ahead and put in, halfway between 0 and 1 is going to be 1/2. So let me extend this page so I can get to it more easily, and we will put in 1/2. So now I've got 1/2 squared plus, sorry, not plus, I'm confusing myself, 1/2 squared minus 1/2 minus 6. Okay, so 1/2 squared, I'm going to write this down below and I'll just change the color here. 1/2 squared is 1/4. Now I've got minus 1/2, sorry, and then minus 6. 1/4 minus 1/2 is going to give me negative 1/4, and then still minus 6. So this is going to give me a, let's make sure, try and line this up, negative 6 and 1/4. Okay, so let's see if we can put that point in. I've got 1/2 and negative 6 and 1/4. But where is that going to be? 1/2 means right in the middle. And negative 6 and 1/4 is right about there. I didn't get it exactly in the middle, but you get the idea. So now let's see how badly this turns out when I try to draw this. I'll try to make this somewhat U-shaped, and I will try to keep my hand steady, but I guarantee I won't do very well. I completely missed that point, but you get the idea. Okay, so this should be a smooth sort of U-shaped parabola. Now, let's see what we have here. We have a vertex. That's this point at the bottom where we change directions. Well, where does that happen at? That happens down here at this function that we found that was right in the middle of the symmetry. And so what do we have there? We have this point, an x value of 1/2 and a y value of negative 6 and 1/4, 1/4. Line of symmetry. Well, that line of symmetry, let's see if I can get halfway in here, goes straight up through there, and I'm way off, but it should go right through my vertex. And so that means when it hits the vertex, its x value is 1/2, and everywhere else its x value is 1/2 as well. So the equation of this line of symmetry is x equals 1/2. And on either side of that line, this parabola is symmetrical. Now, a maximum or a minimum. In this case, we have a minimum. This parabola continues upward indefinitely. But at the vertex, it turns around and it doesn't go any lower. The vertex is the lowest point, and we want to know how low is that lowest point. So what we want is the y value of the vertex. So we're going to put in that negative 6 and 1/4. Okay, parts of an equation. And in this equation, and I'm going to move stuff around here a little bit. In this equation, I want you to identify, well, before I get to that point, we've got a word problem here, and I've written an equation that would be used in solving it. So Victor's car gets 16 miles per gallon of gasoline in the city and 4 miles
per gallon more than that on the highway, write the equation you should use to find the total number of miles Victor can go on the highway with G gallons of gas. Like I say, I gave you the equation. What I want you to do is identify the parts of the equation. So let's look at this. Miles, where would I find miles at? Well, that's a fairly easy one. It's right here. Where are my miles? Okay. Gallons, again, fairly easy. Oops, it would help if I could write. And my gallons are right there. Okay. City mileage rate. Well, let's see. Victor's car gets 16 miles per gallon of gasoline in the city. So this one right here is my city mileage rate. Highway mileage rate. Well, the highway mileage rate was this 16 miles per gallon plus another 4 miles per gallon, because he gets 4 miles per gallon more than that on the highway. So my highway mileage rate is this whole thing here. Okay. Now let's try an equation that's just a touch more complicated. Sprint has a monthly fee of $55 and charges 15 cents per minute for every minute over 2,200. How many minutes did you use if you were charged $65.65? And in the equation, I'm identifying this. The fixed charge, the variable charge, the minutes used, the minutes over the allowance, and this month's charge. So first of all, my fixed charge is right here. This is the amount that I get charged every month, regardless whether I use my phone or not. The variable charge, on the other hand, would be the one that I get charged if I use my phone. So where is that at? Well, it's right here. It's the per minute charge times the number of minutes that I used over my allowance. So this is my variable charge. Okay. How about the minutes used? Okay. Well, my minutes used are, of course, right here. But that's not what I'm charged on. I'm charged on the minutes over the allowance. And that I only get when I subtract out the allowance, right there. And to keep from making this too messy, I'm just going to draw an arrow from where I have this in there. And then this month's charge, well, that's right here. That's what I'm being charged this month. And I'm having you do this because word problems become easier as you begin to understand and see the parts of them, understand how they fit in, and see how equations and word problems are structured. And so I'm having you sort of decompose them a little bit, take them apart into their pieces.